so this is section 3.5, symmetry. How can you tell if a figure, a shape is symmetric? What are we talking about? Well, let's define these things. So you have a figure has symmetry if a rigid motion can map the figure onto itself. In other words, it has symmetry if, let's say, take a triangle. If triangle ABC and the image of that, A prime, B prime, C prime, if they are the same triangle. So if it becomes the exact same triangle, then that is a symmetry. So what kind of symmetries are we talking about? When would this occur? And let's talk about reflection symmetry. Get lined up here. So reflection symmetry is a symmetry for which the reflection maps the figure onto itself. The line of reflections for a reflection symmetry is called the line of symmetry. So how many lines of symmetry does something have? So I drew some ellipses here, some ovals, to show you some of the reflection lines that can occur. You'll notice here, if I reflect this onto here, if I reflect this image, it's literally going to flip over and I'm going to get the exact same image again. The same thing here. If I reflect it across, I'm going to get the exact same image again. Put a mirror right here and see only the top half, and the reflection shows me the bottom half. So it looks exactly the same as the original. Okay? You'll see that lines of reflection occur when it cuts it into exactly equal pieces. So if I can fold it on the dotted line and they line up, that is a line of reflection. So that's a better way to think of it. If I can fold it on that line and the two pieces match up perfectly, then you have a line of symmetry. Okay? It is a reflection symmetry on those lines. That's what this is talking about. You also have rotational symmetry. So in this case, you're going to rotate a figure around some point. Okay? You're going to rotate it. It has to be less than 360 degrees. So if I can turn the whole thing all the way around 360 degrees and it lines up, that is not rotational symmetry. It has to be less than 360 degrees for a rotational symmetry to occur. Okay? Here, if I take this shape and this point right here and I rotate it around that point, if I rotate it 180 degrees around that point, I'm going to get the exact same picture again. So this picture has 180 degrees rotational symmetry. And if that happens in that situation, at 180 rotational symmetry, sometimes it's called a point symmetry. So I'm just going to show you a couple examples. This is fairly simple. What I'm going to ask you to do on the test is kind of identify what I'm going to show you right here. And so you just literally need to draw lines and stuff. So I'm not going to move this example off this page. I'm just going to show it to you. So here's a star, a 5-pointed regular star. What does the word regular mean? So regular shape means all sides are congruent and all angles are congruent. So that's what it means to be a regular shape. So when I said this is a regular 5-pointed star, all of these angles are the same angle and all of these lengths are exactly the same length of the star. So how many lines of symmetry does this star have? Well, take this one right here. If I draw this dotted line right here and then I fold that half onto that half, it's going to match up perfectly. And in fact, because it's regular, that's going to occur at every one of these locations. Okay, at every point. So I drew all 5 of them, so there are 5 lines of symmetry in this shape. Okay, so you're going to be tasked with given a shape to ask whether or not, or how many lines of symmetry does it have, or does it even have any? And you just basically look to see if I can draw a line where I can fold it and it 2 halves match up. That's the key to that one. Now, the next one is rotational symmetry. Does this shape have rotational symmetry? Okay, what are the angles of rotational symmetry? So literally what it is this. So imagine a coordinate system right here, okay? and I have a star on it. And I'm just trying to think the best way to do it. So if I rotate this so that this point is now here, it will look identical to what I see right here. If I rotate it and put that up top, it looks exactly the same. If I rotate this one so it's pointing straight up, it looks exactly the same. So I have all these rotational symmetries. I'm rotating around the center point right here. It has rotational symmetry. So what is those? One time around a circle, one complete revolution is 360 degrees, and I have 5 points. So 360 divided by 5 is 72. So I have symmetry every 72 angles. So the rotational symmetries, and you can't do 360 because all the way around the circle is not a rotational. So I literally have these rotational symmetries right here. So the original figure, okay, and then this one rotates 72, and then this one rotates 144, this one rotates 216, and this one rotates 288. So those are all the rotational symmetries of the star. Okay, so take a look at those, and we'll do practice in class. That is symmetry, the extent that I'm looking for right now. So drawing lines of symmetry and finding angles of rotational symmetry. Okay, and so that ends 3.5.